go. And once again, the following Zoom meeting is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today we're going to start a new chapter. We're going to start section 8.2. We'll be spending 2 days on this. If you have any questions concerning the test you took, email me and I will contact you to go over whatever questions you have one-on-one. Otherwise, we're going to continue on here with chapter 8. So let's get started. So here we go, section 8.2. And today, the main topic we're going to talk about is something called a function. All right, we're going to look at what a function is, how it works, how to deal with it. And this is a topic that will be come up from here on out, the idea of functions. First of all, let me read to you a book definition of a function, and then we'll talk more about it here. Let me put on my glasses. Let's see if I can find the right page. Maybe. Had it earlier. Let's see here. Here we go. A function is a set of ordered pairs in which to each first component there corresponds exactly one second component. The set of first components is called the domain of the function, and the set of second components is called the range of the function. We'll come back to that in a minute, but I have an example I'd like to illustrate. Let's say we have a group of individuals. We have Joe and Maria and Sam and let's see, Miguel. Okay, that's supposed to be a G, believe it or not. And over here we have their birth dates. Joe's birthday is March 9th. Okay. And Maria's birthday is August 17th. Sam's birthday is also August 17th, and Miguel's birthday is June 29th. Okay. Now, so what can we notice about people and their birthdays? Well, each individual has exactly one birthday. You don't have Joe having 2 different birthdays, discounting religious experiences, of course, but each person has exactly one birthday. Maria has the same birthday as Sam, but that's okay because 2 people can share the same birthday. Whether they're twins, they may not even know each other. So several people can have the same birthday. One person cannot have more than one birthday. We're going to call the people, Joe, Maria, Sam, and Miguel, the input. And their birthdays, the output. The way that this situation works, people and their birthdays, is the way that a function works. Let me read the definition again. It says, a function is a set of ordered pairs in which to each first component, so this is going to be the first component, there corresponds exactly one second component. Okay, so we'll call the input or the people's names the first component, the output or the people's birthdays the second component. Again, it says for each first component there corresponds exactly one second component. In other words, each person has exactly one birthday. 2 people can still have exactly one birthday and it be the same birthday, but one person can't have 2 birthdays. Now, in terms of function language, this first component or input is called the domain, and the second component or the output is called the range. So the domain in this case would be the 4 individuals. The range would be their birthdays. Do you have any questions at this point? All right. We're going to take a look at some mathematical examples as to how that works. Let's see here. Let's say we have some ordered pairs. I'm going to use set notation. We've got the ordered pair 7, -1, -1, -11, -5, 3, and 8, -6. All right. So we have ordered pairs, input and output, domain and range. What is the domain of this relation? Well, it would be the inputs or the x values. And I'm going to put them in increasing order. So the domain would be -5, -1, 7, and 8. The range would be the output. So let's see, -11, -6, -1, and 3. So there's the domain and the range. So basically it's the x's are the domain and the y's are the range. Any questions about this example? All right, let's look at another situation. This is known as a mapping. And the left oval, or whatever you want to call it, ellipse there, is the input or the domain, and the right is the range. Is this a mapping that represents a function? Yes or no?
Yes.
Yes, it is. Good. Okay, let's look at another example. Does this mapping represent a function?
No,
Why not?
because, well, the first 2 domains have exactly 1 range, but 0 can't have 2 different second compositions.
Sure, right. So 0 goes to 2 different outputs. So this is not a function. Good. All right. How about this one?
Is there, I had one question. Is there another reason it doesn't work is because it isn't consistent, like the difference between 4 and -6 and -2 and 8 are different?
No, not necessarily, because there might be a way, you could come up with something that perhaps would describe that relationship. So it could still work, but just not be a function. I'm gonna put a pin in that, Roger, and I'm gonna come back to that in just a minute, okay? So,
Okay.
So hold that thought. Let me just do one more example, and then I'll look at something that maybe will clarify it. Maybe it'll cloudy it. We'll see. Cloudy, is that a word? Cloudy it? Okay. 5, 10, 15, and 15. How about that? Is that a function?
No.
Oh, yes, it is. Triplets. 3 different people could have the same birthday.
Okay.
Let me give you an example of an equation, which is a function that would describe this situation. What if we had y equals 15? If x was 5, what would y be? 15. If x was 10, what would y be? 15. If x was 15, what would y be? 15. So that equation which is a function, could describe that situation. But let's look at another example. Let's say we have something y squared equals x, okay? I'm not going to get into all the detail of it right now, but I could graph that thing and it would look something like, let's see if I got this right. I think it would look something like this, okay? Roughly speaking. So that's an equation that has a graph, but let's deal with it in terms of, is it a function? Well, if x is 4, could y equal -2? If I put -2 here and squared it, what would I get? Isn't -2 squared equal to 4? Are you seeing this or not?
Yes, yes, it is.
What if y was 2? Wouldn't 2 squared also equal 4? So here's an equation. I can graph it, but it's not a function because you've got an input going to 2 different outputs. So it's an equation, but it's not a function. A function has particular characteristics that are predictable. Each input goes to exactly one output. Let's look at some more examples here. Let's see, 3, 4, 3, -4, 4, 3, 4, -3. Making these things, that's the hardest thing I have to do, I think. That's what this is supposed to be. All right, is this a function or not?
It is not.
Why not? Can you give me 2 ordered pair examples to show that it's not a function?
Yeah, 3/4 and 3/-4.
And why does that show that it's not a function?
Because the 3 can't have 2 different exponents.
Not exponents,
Or sorry,
outputs.
outputs. Sorry, that's the
That's
one.
okay. No, yeah, that's all right. In fact, let's go back and let's look at some vocabulary. The domain is the input. Is the x value, is the cause. The range is the output, is the y value, is the effect. How many of you went out in the rain yesterday? Anybody?
I did.
Did you put on a coat?
No.
Did you put on a jacket? Anything special because of the rain?
No, I just like being in the rain sometimes.
This is not working. Is there anyone who put on warmer clothes because it was raining? Anybody?
Me. Oh my goodness.
Okay, great. So Sydney, what'd you put on because it was raining?
It was just a jacket. But
Okay, so let me ask you this. Did you put on the jacket because it was raining? Or was it raining because you put on the jacket?
you put on the jacket because it's raining,
Right, you don't control the weather, do you?
unfortunately.
Unfortunately, that's right. So the domain, the cause would be the rain. The range or the effect would be you put on a jacket. Does that make sense?
Mhm.
Okay. I'm going to write down one more thing on my list here. I'm going to say independent variable dependent. See, is it ANT or ENT? Dependent. I think it might be ENT. Variable. We'll never know. Okay,
Sorry for ruining your example there.
that's okay. It's all right. It didn't ruin it. I'll get what I want somehow or other. All right. So the dependent variable is dependent on the independent variable. The independent variable is the weather. It's raining. You didn't get to choose it. It's raining. But you're dependent on that. You put on a jacket. Some of you, those of you that didn't want to catch cold. Okay. All right. Let's take a look at something else here. And this has to do with notation. There is some special notation that we use when we're dealing with a function. Okay. Let's take, for instance, the equation y equals 2x plus 3. So that is an equation. It's a linear equation. Its graph is a straight line. It has a y-intercept of a 3. It has a slope of a 2, all of that stuff. Let's find some ordered pairs that are solutions to this equation. All right. Suppose x is -1. How would we find y?
You're going to plug in -1 into x.
Plug in -1 for x, okay? So y equals 2 times -1 plus 3, which is -2 plus 3, which is 1. So when x is -1, y is 1. All right? Suppose x is 0. How would you find out what y is?
Plug it in.
What?
Plug it into x.
Plug it in for x? Sure, do the same thing. Sorry, I could just barely hear you there. All right. And 2 times 0 plus 3 is 0 plus 3, which is 3, right? How about if x is 1? How would you find y?
Plug it in.
Plug it in.
Plug it in for x, right?
Mhm.
Or you could be really lazy and just say, same thing. And if x is 2, y equals 2 times 2 plus 3, which is 4 plus 3, which is 7. Okay? Now, y equals 2x plus 3 not only is an equation, it is a function. For each input that I put in there, I'm going to get just one unique output. Okay? And we'll talk more about that later. But because it's a function, there is a different symbol that we're going to use in place of y. And that symbol looks like this. Now, that's sort of an italicized F. This symbol, the way you say it, is f of x. It's a shortcut notation for saying f is a function of x. F of x is just another name for y. So, or another symbol for y. So if I take the equation y equals 2x plus 3, and I just declare that it is a function, which it is, I can also write it f of x equals 2x plus 3. Now again, f of x is a symbol replacing y. Now, I kept saying it's a symbol. So it's not f times x. It looks like f times x, though, doesn't it? Because parentheses around the x, if we have a number or a letter next to something with parentheses, we tend to say, oh, it's multiplication. So it looks like f times x, but it's not. If we go back to our Math 75 percentage days, 7 is 3% of what number? The word of can be multiplication in that context. So saying f of x sounds like multiplication. So it looks like multiplication. It sounds like multiplication, but it's not multiplication. It's just a single symbol to replace y. Okay, now, how do we use that? Well, we're going to find the same ordered pairs that we found over here, but using function notation. If I want to know what y is when x is -1, I would say f of -1 equals. Notice I'm putting the input on the inside in place of the x. How would I find the corresponding y value? The same way I did using the equation notation. I'd put -1 in the place of x. Whoops, that's supposed to be a plus sign. So basically f of -1 equals 1. That is the function notation way of saying the ordered pair -1, 1. So here is the ordered pair in a table. Here it is as a regular ordered pair. Here it is as function notation. So for the function, f of x equals 2x plus 3. F of -1 equals 1. What would f of 0 equal? Well, it would equal 2 times 0 plus 3, or 3. So f of 0 equals 3. What would f of 1 equal?
Five.
Good. And you could find that two ways. You could calculate it, or you could just look over here and say, oh, well, it's 5, right? Okay. All right. Any questions about that idea? Okay. So let's deal with some new functions and evaluating them for specific x or input values. Let's say I have f of x equals -4. And I want to find f of 3 and f of -1. So if f of x, oops, I wrote that incorrectly. Sorry, I wanted to say f of x equals -4x. There we go. Let's find f of 3 and f of -1. So f of 3 would be -4 times 3, or -12. So f of 3 equals -12. That's function notation for the ordered pair 3, -12, which is a point on the graph over here at 3 and down here at -12. Okay. So really, we haven't changed anything other than we've introduced a new way of labeling the same old stuff. Okay. F of -1 would be -4 times -1, which is 4. So f of -1 equals 4. That corresponds to the ordered pair -1, 4, which corresponds to the point -1, 4, etc., etc. All right. Any questions there? Okay. How about this one? G of x. Oh, wait a minute. What happened to f? Well, just like we can use any letter in an equation, we tend to use x's and y's, but it's not limited to that. We can have function notation using things other than f of x. G of x, for instance. So this is g of x equals x squared minus 2. In fact, let's expand on that a little bit. If this was Math 111, a business algebra class, and we were talking about profit and revenue and cost, we might have a cost function, c of x equals something, a revenue function, r of x equals something, a profit function, p of x equals something. So oftentimes the first letter will stand for something specific, okay? So it isn't limited to just f of x. All right, back to our problem. G of x equals x squared minus 2. We are to find g of 2 and g of 3. So g of 2 would be 2 squared minus 2, which is 4 minus 2, which is 2. G of 3 would be 3 squared minus 2, which is 9 minus 2, which is 7. If I were to graph this function, the point 2, 2 and 3, 7 would be on that graph. Okay, so G of 2 equals 2, that's like the ordered pair 2, 2. G of 3 equals 7, that's like the ordered pair 3, 7. Any questions? All right. How about this? G of X equals the quantity X minus 3 squared. We're going to find G of 2 and G of 3. All right. So the first thing I do is I put the 2 in the place of X on the right side of the equal sign. Then, following order of operations, inside the parentheses first, 2 minus 3 is -1. Applying the exponent, -1 squared is -1 times -1, which is 1. So G of 2 equals 1, which again corresponds to the ordered pair 2, 1. G of 3 equals, parentheses, 3 minus 3, the quantity squared. Order of operations, inside the parentheses first, 3 minus 3 is 0. 0 squared is 0. So G of 3 equals 0, which corresponds to the ordered pair 3, 0. Any question there? Righty. Let's see here. Oh, let's see if you remember what this means. That X inside vertical bars. Can anybody tell me what that vertical bar notation is?
Absolute
It's the
value.
absolute value.
Good job, folks. Good job. All right. We're supposed to find H of 5 and H of -2. So H of 5 would be the absolute value of 5 minus 5. What is the absolute value of 5?
5.
And what is 5 minus 5?
0.
Good. Second value, H of -2, would be the absolute value of -2 minus 5. What is the absolute value of -2?
2,
Good. And 2 minus 5 is?
-3.
-3. Excellent. Any questions about that? All right. Let's take the function h of x equals 3 over x minus 4. Let's find h of 5 and h of -2. So once again, we're going to put the 5 in the place of x. So we'll get 3 over 5 minus 4, which is 3 over 1, which is 3. So h of 5 equals 3. Let's find h of -2. So we'll put -2 in the place of x, 3 over the quantity -2 minus 4, which is 3 over -6, which reduces down to -1/2 or -1/2. But you would put the negative sign either in the numerator or out in front, but you wouldn't leave it in the denominator. All right, questions there? Okay, how about this one? H of x equals x squared plus 2x minus 35 all over x squared plus 5x plus 6. We're going to find h of 5 and then h of -2. Okay. So every place that x appears, we have to put a 5. So in the numerator, we're going to get 5 squared plus 2 times 5 minus 35 over 5 squared plus 5 times 5 plus 6. In the numerator, 5 squared is 25, plus 2 times 5 is 10, minus 35. In the denominator, 5 squared is 25, plus 5 times 5 is 25 plus 6. In the numerator, 25 plus 10 is 35, minus 35 is 0. In the denominator, 25 plus 25 is 50, plus 6 is 56. But what is 0 divided by 56?
Undefined?
No. When is it
Zero.
undefined?
I don't know. I thought it was something.
It's undefined when it's divided by 0.
Oh, shoot.
Yeah.
Sorry.
So 0 divided by 56 is 0. But if it was 56 divided by 0, that's when it's undefined. Okay. All right, let's find h of -2. So that's going to be -2 the quantity squared plus 2 times -2 minus 35 over -2 the quantity squared plus 5 times -2 plus 6. -2 the quantity squared is 4, plus -4 is -4, minus 35, over -2 the quantity squared, which is 4, minus 10 plus 6, which is -35 over 0, which is,
Undefined.
there you go. You've redeemed yourself. So now, this has a special meaning for us. When we put -2 into this function, we did not get a real answer. We got undefined. That means that -2 is not in the domain of the function. If you put something into a function, but you don't get something real out as the output, then what you put in is not an acceptable input. It's not part of the domain. Let me give you a story from my childhood. When I was born, I lived out north of Sealy in the Weenass Valley. And I remember that my mother had this meat grinder that was made out of pot metal. Pot metal is not very strong, okay? It's pretty cheap stuff. And she would take roast beef, chunk of roast beef, stick it in this meat grinder, turn the crank, and it would come out. It kind of looked like worms. It sort of looked gross, but it tasted great. It just kind of came out like spaghetti sort of things. Anyway, so meat goes in, grind it up, ground meat comes out. Well, my brother decided to put a rock in the meat grinder. What do you think happened?
Did it break it?
There you go. It wasn't a rock grinder, it was a meat grinder. So putting a rock in a meat grinder is not a good idea. It did not produce good results. So a rock is not in the domain of the meat grinder function, so to speak. And by the way, if you ever see my brother, that story's made up, so don't blame him. Okay, now, at least I think so. So -2 is not in the domain of this function because it, in effect, breaks the meat grinder. It gives us undefined. So that's not a real output. Now, 5, on the other hand, gives us 0. 0, that's real. That's okay. You just can't have an answer where you're dividing by 0. All right. 0 is a real number. It shows up in my checkbook all the time. Okay. Let's take a look at some more functions. Now things are going to get a little trickier. Let's say I have g of x equals 3x minus 5. Okay. What would g of 1 equal? And don't just give me the answer, give me the specifics. What's the first thing it would give you? It would give you what?
3 minus 5.
3 times 1 minus 5, right? Which is 3 minus 5, which is?
-2.
Right, okay. What would g of star give you? Don't overthink this.
It would be 3 times star minus 5.
Right. How about g of Barbie? What would g of Barbie give you?
G times, no, 3 times Barbie minus 5.
Right. How about let's bring let's see, Skipper. G of Skipper. Wasn't Skipper Barbie's friend?
She's Barbie's sister.
Oh, well, can't your sister be your friend? Sorry, I'm not an expert, but I'll try my best.
I have two sisters, okay? That's my excuse.
There you go. So what's G of Skipper?
3 times Skipper minus 5.
All right, how about G of G.I. Joe? Let's see. G.I. Joe. What would G of G.I. Joe be?
3 times G.I. Joe minus 5.
Right. Are you seeing a pattern?
Yes.
Don't overthink it. In fact, in general, we could say G of equals 3 times minus 5. G of equals 3 times minus 5. Whatever goes in here goes in there. Don't overthink it. Okay? Now, let's go back to this. What would G of W equal? This is not a trick question.
Wouldn't it be 3x times w minus 5?
Was this 3 star times or 3x times star? What did the star do? Think about it, Roger. What did the star do? What did Barbie do? What did Skipper do? What did G.I. Joe do? It replaced
It replaces x.
So what's G of W?
3w minus 5.
Right. It's not 3x times W, it's 3w. W is replacing x. See it?
Okay.
You were fine with Barbie and Skipper and G.I. Joe, but what's with W? How about G of Walter? Wouldn't that be 3 times Walter? Well,
Yeah.
all right, here we go. What about G of W plus 1? What would that be?
3 times, oh, well, 3 in parentheses, W plus 1, and then minus 5.
Yeah, so 3 times the quantity W plus 1. So that would be 3W minus 2, wouldn't it? Because W plus 1, that quantity is replacing X. Okay? Now we're going to play Jeopardy. I'm going to tell you the answer and you're going to give me the question. Suppose that f of x equals negative 2x plus 5. For what value of x does the function f have the given value? F of x equals 5. So I'm telling you the output. I'm telling you the answer. You have to tell me the question or the input. What are we going to put in? So f of what is going to equal 5? Well, when would f of x equal 5? Let's see. 5 is when it's negative 2x plus 5. Subtract 5 from both sides. 0 equals negative 2x. Divide by negative 2. X equals 0. Okay. So f of 0 equals 5. What do you have to put in to get 5 out? You have to put 0 in to the function to get 5 out of the function. How did I determine that? Well, I wanted 5 to be the output. So I said, when is f of x equal to 5? Well, when is this equal to 5? When x is 0. So that was a case of, it'd be like saying y equals negative 2x plus 5. Complete the given ordered pair. Okay. So you put 5 in for y and solve for x. In this case, we put 5 in for f of x and solved for x. Let's do another one of these because I suspect there is some question there. Let's see. F of x equals 3/2 x minus 2. For what value of x is f of x equal to -1/2? So what value of x put in gives me a value of y, or f of x is -1/2. So what would my next step be? We would put -1/2 in the place of f of x because it says f of x is -1/2. Now we're going to solve for x. Okay. Do you want to clear the fractions or just leave them there for now?
Just leave them there.
All right. So we'll add 2 to both sides. What's 2 minus 1/2?
1.5.
Okay. 1.5 is the same thing as what? 3/2? Is that right? Yeah. So when you have a coefficient that's a fraction times the variable, what do you multiply by to get rid of that 3/2 in front of the x? Do you remember?
Oh, they're reciprocal.
Which would be 2/3. So x equals 1. In other words, f of 1 equals -1/2. For what value of x would the output be -1/2 for x equals 1? Okay.
Okay.
Now, we're going to find the domain of each function. F of x equals 2x plus 1. So the question is this: is there any value of x, any real number that we could put in the place of x, take 2 times that plus 1 and get something that's not real? The answer is no. Any value we put in there, a real number times 2 is still a real number, plus 1 is still a real number. So the domain would be all real numbers. Now, back in chapter 2, if you took Math 85, and if you didn't, well, then you could refer back to, I think it's section 2.7. It talks about something called interval notation. How do you say all real numbers in interval notation? Well, it's everything from -infinity up to +infinity, but you don't use brackets on either side. The parentheses means that -infinity goes forever to the left and +infinity goes forever to the right. Okay, so the domain is all real numbers. It's everything from -infinity to +infinity. Now, let's look at another example. Find the domain of f of x equals 1 over x minus 4. There's potential trouble here. What if x equals 4? F of 4 would be 1 over 4 minus 4, which is 1 over 0, which is undefined. So x cannot equal 4. So the domain would be x can't equal 4. Or you could say all real numbers except 4. In interval notation, this is where things get a little tricky. It would be everything from -infinity up to but not including 4. in union with everything after 4 going on up to positive infinity. Now, what's going on there? Well, parentheses means you don't include the endpoint. You don't include negative infinity because that goes to a negative direction forever. You go up to, but you're not including 4. So you're including like 3.999999999, just keeps going, but right up to, but not including 4. And then along with, so there's a union symbol, starting right after 4, so 4.0000000000001 kind of thing, on up to infinity. Now, this is not nearly as efficient as this is, but interval notation, which is what that is something that you will need to know and will be using, okay? All right. How about this one? H of x equals 15 over 1 minus 3x. What is the domain? Well, we don't want the denominator to be 0. So when is that true? Well, let's see. If we add 3x to both sides and we divide by 3, we get x equals 1/3. So we don't want x to be 1/3 because it makes the denominator 0. So the domain would be from negative infinity up to, but not including 1/3, and from 1/3 on to infinity. Okay? Everything but 1/3. Now, one last idea. Y equals 2x plus 4. If we were going to graph that thing, we could use y equals mx plus b. The slope would be 2, and the y-intercept would be 4. I'm not going to switch over to the graph right now because we're limited for time. The y-intercept of 4 would be there. The slope would go what? Up 2 and over 1, up 2 and over 1, and we'd get this graph. And again, I could open up the graphing stuff, but I'm not going to do that right now. So y equals 2x plus 4, y equals mx plus b, or you could what? You could use ordered pairs, like let x equal 0 and 1 and 2 and find those points and draw the line, okay? As a function, if we had f of x equals 2x plus 4, that's the same thing as that. It's just written as a function. So this is like f of x equals mx plus b. It still has a slope of 2 and a y-intercept of 4. So you'd be plotting the exact same points. You should get the exact same graph. Likewise, you could make a table and you could put in an x value and then find f of 0, etc., etc. So don't go out and create an entire new universe based on function notation. Functions are equations. They behave like equations. They just behave like specific equations where for each input, there is exactly one output. All right. So tonight, we're going to tackle section 8.2. The first half of it. We'll come back tomorrow and look at the rest of it. Any questions before we go?
Oh, I did want to ask you, do we need to email you about like our grade, or is there a way that we can like
Email me.
calculate it ourselves? Okay.
There is. Basically, at this point, this is how I would calculate it. You would take your test, how many you got right, divided by how many were possible. And then turn that into a percentage. You've had 2 tests, so you'd average those 2. Okay. So that's your test score at this point. Your homework, again, you take how many possible divided by how many you got right divided by how many possible. The thing is, with the tests, you would average those. With the homework, you would just total them. And if that's confusing, email me and I'll send it all back to you, okay?
All right, thank you.
You're welcome. All right, we're going to stop the recording.